Hey guys, so this tutorial I'm going to kind of try and give you guys an introduction to OpenGL in Max. Turn the caps off there. But basically what I'm getting at with OpenGL um, is I'm trying to show you how you can start to render things on your GPU. So right now, everything we've been doing has been on our CPU. And our CPU is like, it's great, it's fine, it does a lot of things, but it's really inefficient for video processing. And our GPU is where we actually want to do most of our pixel-based processing. It also is where we're going to start doing things like 3D animations and whatnot. And really the biggest difference you're going to have, well, there's a few differences, but right off the back, excuse me, uh, anything that has JIT as the beginning of it is CPU based, and anything that has jit.gl is actually going to be GPU based. So we're going to look at like what this is kind of like almost a separate library of jitter with its own like its own way of working, its own things that we have to get a handle on. And basically, the reason that these things are different is like we actually have an API. This is OpenGL is kind of like an API for communicating with our graphics card. And what's nice about what you're learning from this style of doing things is it's actually pretty consistent with other programming languages. Like you can do things in OpenGL or on the GPU with a lot of other languages, obviously. But what we're actually doing is using Max as a wrapper for communicating with our graphics card. And the concepts are kind of the same. If you want to do this in open frameworks or if you want to do this in Unreal Engine, we're going to talk about shaders. We're going to talk about draw calls. So yeah, that's just me prattling on. If you want a better explanation of this, I recommend checking out the Book of Shaders. But I think his name is Patricio Gonzalez. I think that's how you spell his name. And I'll get into what shaders are in just a second or further down. But like just even in terms of like the difference between the CPU and the GPU. He gives a really nice explanation, and it's actually just a web page. It's not an actual book. So let's take a step back and actually start writing some code, because that's probably why you're here. In the past, like if we wanted to do something like play a camera or just get a camera feed in here, I would do qmetro and give that 33 and a toggle. In jit.grab, in jit window, and the message open, and I'll make my window app floating 1. So we can just put it in the corner here. And then I'll turn it on, and there we go. There's me, there's our CPU-based code, and this is how we've been used to doing things. One thing that really happens a lot with the CPU-based objects is you're kind of connecting everything. We're actually going to throw that out the window a little bit. Not completely, but let's look at how we could take this and set it up to actually be running on the GPU. So I'm going to get rid of this because you should know this by this point. I'm going to show you the hard way to do it first because it's actually really important towards understanding what's happening. I'm going to make an object called jit.gl.render. And I'm going to give it a name, and I'll give it the name lip for the name of our class. The name is arbitrary. You can choose whatever name you want. It's the first argument after jit.gl.render. The only thing you have to make sure is that you consistently use this name. And yeah, if you're going to connect things, use an underscore. Like I couldn't do lip class, obviously, or maybe not so obviously, but if there's a space right here, it's going to disconnect. So we'll do lip. And then I guess I'll talk about what this is doing first of all. This is basically our renderer. Everything that we're going to be asking our GPU to do, this object is in charge of. It's almost like our draw function that we use in other languages. We're going to be asking us to draw all the stuff that has to be rendered on our GPU. And so this is kind of the engine, if you will, and when we're doing this stuff. Like anytime you do anything with jit.gl, this is an object you need. And we have to set it up a little differently than we've done other objects in the past. So I'm going to take trigger as an object. You remember, like, triggers, I love this object. It's once you start getting more into Max, you start to realize why it's so important. But trigger just lets me make a lot of things, like trigger, bang, bang, bang. And if I give it a bang, you see that for each of these bangs that I wrote, it has a different outlet. And it says output order 2, bang, output order 3, bang. So it lets me chain together multiple things happening from one bang. And I could also, it doesn't have to be a bang. It could be, I could put a message here like clear. And now it passes that message clear. I could also add a 12 here. Oops. And I make an integer box, and I'll pass 12 along. And one thing that's cool is, like, also if you actually just use like an I for integer, it doesn't need a bang to trigger. Anytime it receives any information, it'll pass that along if I have the right, not acronym, but if I have the right symbol right there. And you'll notice that it's also like tying together. If 37, 38 comes out, it's also going to send that bang and that clear message and whatnot. And yeah, I love this. Also, the really important thing is, like, it's actually coming out in this order. So when you get into more complex patches where you need things to happen in a certain order, this is how you chain stuff to make sure that it happens in a very distinct order. So, and it goes from the first inlet all the way over to the right. So kind of confusingly, this would be the last thing that happens, and this would be the first thing that happens. So I'm going to use that object, and I'm going to say trigger, bang, bang, erase. And I'm going to hook up that first bang and that erase message to jit.gl.render right here. And why are we doing that? Because I'm also going to hook up a qmetro 33 and a toggle. And now, if we turn this on, I mean, nothing's going to happen, but what is happening is every 30 times a second, it's sending the message erase to jit.gl.render, and then we have this bang in the middle that I'll explain in a second, and then it sends a bang. So it goes erase, bang, erase, bang, erase, bang, 30 times a second. And that's us telling it to flush everything out of what it had been doing before, to erase everything that it had rendered in the previous frame. And the bang is to update and draw the next frame. So it's like our draw loop. We're trying to tell it to, like, erase everything you did before and update to the next frame. And we do 33 because that means 30 times a second, 30 frames a second. If we want 60 frames a second, we could do qmetro 16. So yeah. Sorry, I'm getting over a cold, but just give me 1 second. Now, I'll get to this middle bang in a second, but first the next thing I want to make is I want to make a JIT window. But here's where things differ with OpenGL. I am going to give it the name lip. And I'm also going to give it that floating 1 argument. And I'm not going to hook up anything to JIT window, which goes against everything that we've been doing with Max already. And the reason is because jit.gl.render typically relies on shared namespaces. So almost all jit.gl objects are looking for what is rendering it, and the renderer is going out and finding all GL objects that work with, they're finding all GL objects that share that name, and it's saying, oh, my job is to render that object, so I'll take care of that. Confusingly enough, there's no jit.gl window, That's because JIT window has many functions both in the CPU and the GPU type land. But now, if we actually turn it on, you'll see that the screen turns a little gray. Maybe it's a little hard to pick up at first, but I could also do, just to show you what's going on, I could do add erase color. I'll do 1, 1, 1, 1. So red, green, blue, alpha. And what this does is it changes my, I guess you could say, background, but what's actually happening is we're looking at three-dimensional space right now. This render object is actually creating a vast infinite void of three-dimensionality. And our JIT window object is now a viewing portal into that 3D space. And right now we don't see anything because we haven't rendered anything in it. And this attribute right here is just telling it that, like, I'm erasing the color to set it to have the whole infinite void space be white. And that now you can just tell that something's happening. I guess now that I turned it on, it's not going to turn that off. But the next thing we could do is I could make an object called jit.gl.gridShape. And you can see it says here, generate simple geometric shapes as a grid. And I'm going to say lip. I'm going to give it that name. And I am going to say @shape. And let's do torus, like a donut shape. I'm going to hit enter and you'll see something happen. I'm going to add another thing in. And now we have this. And oh my gosh, crazy. Like, why do we have a sphere? Well, actually what's happening is it's just too big. So I'm going to say @scale 0.3, 0.3, 0.3. So I'm going to scale it down. I need to give it 3 dimensions, the x, y, and z. And now we have our little 3D shape in our 3D environment. And that's where this JIT window object is coming into play. It's like giving us a porthole. You know, almost imagine if we were in like a submarine or something, and we were going through the ocean, except this ocean happens to be 3-dimensional space, and you look out the porthole. JIT window is basically like a porthole that we can move around of like what we're viewing and where we're looking. And as a default, almost all objects will go to the center position of what's in this window. We're at like kind of a 0, 0, 0 state right in the center there right now. I can give it some other arguments as well. I could say like @lighting enable. I'll do 1. And now you can see we've got kind of a nice little geometric grid shape. I'm also going to make an object called jit.gl handle. And it says use mouse movement to control position and rotation, and I'll call it lip. And what this allows me to do is now I can actually click on my window and move that 3D object around. It creates that kind of gumball interaction right here. Without this object, I can't do that. And you'll notice, like, what's happening, none of these objects are hooked up. Like, there's no cords being drawn. It's all just that this object right here is going out and looking for things that have the same name. And it's like, my job is to render all that. So that's pretty cool, right? Like, it's a little basic at first, but all of this is running on your GPU, so it should be pretty efficient. Let's take a step back, though. Like, we'll keep all of this, but what's going on with this middle bang here? Well, we can still use CPU objects, and we actually do want to use CPU objects for a lot of things, but we want to convert it into GPU space. So I'm going to make an object called sendDraw, and I don't know if some of you haven't seen this yet, but the send and receive objects, as long as they share a name, this is almost like this is like a network for sending information in Max. So I could do, if I just actually hook up a bang to it, you can see that's happening. Maybe it's a little more obvious if I make a counter object. And this is true for any, if I can make as many of these as I want. Anything that says receive and has the same name will receive whatever is being sent to sendDraw. So why would I want to do that? The reason is because I still might want to make things like Jit, I'm going to turn this off. It seems like the computer's overheating a little bit. I'm like worried maybe I'm running out of space. We'll find out what happens. So I could make my jit grab. I can do open. And now, instead of making a Q metro for it, though, I'm just going to say receive draw. And the reason we're doing this is anything that we want updated in between the render erasing its previous contents and then getting a bang to update its new contents, we'll do with this middle bang. This becomes our kind of Q metro that we're hooking up things to. And its job is to kind of go out in between that erase and that bang state and say like, hey, you guys need to update. And right now we're updating this jit grab frame. And what you wouldn't want to do is this, although that seems like what we would want to do. But now we get this weird flickering thing. And it actually makes a lot of sense what's happening. This JIT window object has two jobs now. It has a job to render the 3D environment and also show this CPU-based image that it's being sent. And the flickering is because these are linked up now, this Q metro and this receive. It's actually fighting for which one it's trying to represent. It's like, oh, I'm supposed to show this, and I'm supposed to show this, and this, and this, and this, and over and over and over. So that's not really what we want to happen. But what we have coming out of here, this matrix, you know, like when we talk about like JIT cell block, where we can like look at like what all the pixel values are that are coming out. That kind of two-dimensional information is referred to as a texture in this GL space. So I'm going to make a jit.gl texture, and I'm going to give it the name lip. And now, what's really cool is these grid shapes, these 3D objects, will accept a texture. The texture is basically whatever is the skin around a 3D object. So I could just hook that up here. And it's kind of hard to tell, but you can kind of see my head in there. It's wrapping that two-dimensional image around our 3D object. I think if I turn the lighting enable off, it'll be more apparent. Or I guess I can put a 0 there. And you can see, yeah, it's our I get this kind of weird zoom in with my head and whatnot. And we could do other shapes too. I could do shape cube. And that's a little more obvious of what's happening here. And that's pretty cool. And that's like all, you know, that makes sense and stuff, but what I really think is going to be more beneficial for the things that you guys are exploring is we still want to do all the 2D stuff that we have been doing in terms of like cameras and movie playback and stuff. And 3D objects are their own thing that you can totally explore, and I encourage you to. But what we really want to figure out is how do we just do all the stuff that we were doing before, but do it on the GPU? Because the reason we want to do that is it's so much more efficient. It's like so much better in terms of like our frame rate and our computer not slowing down. So not to scare you, but I'm going to delete all of this. And I'm going to show you the easy way to do what we were doing before. And that's with an object that's fairly new to Macs called jit.world. And I'll give it the name lip. And I'll make a toggle. And this middle outlet here says render draw bang, so that's where I'm going to be doing that send draw. And all of this, just these three things right here, that replaces our jit.gl.render, our jit window, our Q metro. All of that is now baked into this individual object right here. And I can give it the arguments that I would have given any of these three objects, like @floating1. Or if I wanted to change the speed, oops, sorry, I didn't get that quite right. I can say at FPS, which is a little bit, it's like not the Q metro speed, but now it's just like looking in terms of frames per second. I could just say 60. So what I want to say though is this method that I showed you before and this method right here have absolutely no difference as far as I know in terms of performance or behavior. There might be a few bugs or something, but they're pretty obscure. They just realized, oh, let's make this simpler. Let's all wrap this up into one object. So the reason I explained that previous version is you might run into that in other people's code, and it's good to know what actually is happening in this object that's doing all that rendering for you. So I'm going to do this. I'm going to make a JIT movie. I'll say read. I'll do my receive draw. And I just want to render this movie as a normal two-dimensional movie on my screen right here. And one way we could do that is we could do jit.gl grid shape. And I'll give that lip, and I'll say at shape plane. And I'll do my jit.gl texture lip. I'll read a movie. And this is pretty close to what we were talking about, because it's literally just making a two-dimensional plane, and we're rendering it to that two-dimensional plane. And that plane right now happens to be in the position that it looks like it's part of our movie here. And I could, I could scale it. And I could even rotate it, which you'll start to see how this works basically. Yeah, you can see it's just a two-dimensional plane. Now, the better way to do this, although not totally necessary, is basically Max was like, oh, people just want to use the GPU to render movies and videos in two-dimensional information. So they made an object called jit.gl video plane. And it's literally what it says it is. It's a plane, but it's meant to be used for showing video. And what's nice about it is it always automatically fits whatever the window is. And now I can just hook that up there. And like the shading's right, so our coloring's right. And I can give it the argument at transform reset to, which I know seems like, what the fuck does that mean? Why would I put that? It has to do with like projection transforms and model views. But basically what it does is it just resizes the video plane to fit the window no matter what the dimension is, like this. And this is pretty much it. And actually we can make it even simpler, because this is converting our CPU-based image into a texture. We could also just say at output texture, and now I think it's more efficient, but it might just be the same. But basically now we're guaranteed to have a texture come out. And that's kind of it. Like, the easiest way to think of it sometimes is that our jit.gl video plane kind of replaces how we use jit window. Like, that's kind of our final draw loop, or sorry, it's our final, like, place to hook things up to visualize it. But there's one tricky thing. I mean, there's lots of tricky things, but the one thing that, like, is going to keep us from, like, doing what we were doing before is now, if I make jit vercosa and I hook it up here, and so far everything seems to be working. I'll make my message brightness $1. And absolutely nothing is happening. What's going on here? Well, sometimes we don't do this enough, but let's open up the Max console. Oh my goodness, look at that. It says jit.world doesn't understand jit.gl texture. What's going on is now that we have everything rendered as a texture, it's not going to work with our CPU-based objects. Its CPU object is expecting a JIT matrix. So I regret to inform you that all the objects you had been using up until this point in class are no longer quite relevant to what you're doing. The rule of thumb is once it's on the GPU, it should stay on the GPU. So I mean, you could we could use the jit.world before we get to the jit.gl texture and render it down. That's totally fine. You're just not going to get the performance boost. Everything you do on the CPU is going to cause more and more loss of rendering time, or I guess I should say frame rate. So this is kind of, we could say JIT matrix and convert it back to the CPU, and now it works. But this is kind of pointless because now we're bringing it back to CPU and then back to GPU here. So it's just not what we're trying to do here. We want to keep it on the GPU so we get all these performance gains. So how do we do that? Well, how do I control the brightness? This is where shaders come into play. And they are a bit esoteric, and I'm not going to teach you how to write shaders, but I'm going to teach you how to use shaders. Shaders come in two flavors. There's a vertex shader, and there's a fragment shader. I've never done anything with vertex shaders, but basically, as far as I know with vertex shaders, is the vertices of a 3D object. I don't know why I'm referencing this, because I guess this used to be a 3D object. It's a video plane. Anyway, vertex shader would be manipulating the three-dimensionality of something. You could change the vertex, vertice points. But we don't really care about that, especially for what we're doing. Fragment shader is doing pixel calculations, basically. It's fragment is just what is rendered to the screen in terms of pixel by pixel location. And this is where we can recreate a lot of the JIT objects that we've been using. And in order to do that, and this is going to seem really esoteric, but we need something. We can do it two ways. Yeah, two ways. We can do that with JXS files, and we can do it with an object called jit.gl.pix. I'll start with JXS files. I'm going to make an object called jit.gl.slab. I'll give it the name lip. And then I'm going to say @file cc.precosa.jxs, which probably looks a little esoteric. But if I lock the patch and double click on this now, it's actually going to bring up all of this shader code that is essentially going to do the same thing as our jit.world object. And you can see why I'm not going to teach you how to write this. It's pretty low-level stuff. I'm at the point where I can read shader code to a certain extent, and I can steal shader code and convert it. But I can't write this from scratch. I can't have an idea and just be oh, I'll whip that up with a fragment shader. But Max has a lot of these JXS files for you to play with. If you go to help examples, jitter examples, render, slab helpers, here's a color, and you can see alpha glue, brightness, color map, contrast, plane map, saturate, slide, just like we had the JIT slide object, texture displacement. There's a lot of really cool, and it's nice because it's all rendered in the GPU. You can actually do more complex pixel shifting kind of stuff. And I know this looks intimidating, but all you really need to know is what are the parameters of it? What's it supposed to do? This modifies image contrast by interpolating, yada, yada, yada. It's called Vertex. It does the same thing as jit.world. And if I look at the parameter names, there's contrast, brightness, and saturation. And really the biggest difference is when passing, if I make a message, I can do this. But now I have to put the word param in front of it, as in parameter. And that's it. This is how we use shaders and how we replace some of those CPU JIT objects with something that can run on our GPU. And all you need to know with this object is that you just have to put the word param in front of any of the parameters. And yeah, like our performance gains are like through the roof when we start doing everything with this. But it's tricky. Like I said, once it's on the GPU, it should stay on the GPU, and it's going to be on you to find. You know, if you go to the forums and stuff, you might be able to find like people that have already written JXS files. They might be hiding in some of these Max example folders. And yeah, it's going to take you pretty far. Just as a slight addendum, I use these sometimes. There's also jit.gl picks. And this is a new thing to Max. And what it does is it lets you write shader code with a Max-like programming environment. And this looks like Max, right? But if I type jit precosa in here, nothing comes up. That's because all of the functions, all of the objects that are available in jit.gl picks are only what's available within shader code. So I can say like sample, or I can say swizz RGB. I could say, clamp, clamp values to specified range. And this is cool, and some people, they can get some really great stuff going with this. But this works best if you actually understand shader code, because that's what it's trying to recreate. It's just writing shaders with what is available to shader code in a Max-like environment. And it all translates to the same stuff that this is. So there are some examples of that. If you go to JIT or help examples, jitter examples, gen, you can see like there's like an alpha blend jit.gl picks. There's a mirror one. Why don't we just grab that one and open it and try it out? And you can see it's offset the mirroring of what we have coming in jit grab. And you probably recognize this. Like they decided not to do like a middle bang right there, but otherwise it's the exact same. If you don't offer a name for jit.gl.render, it'll just work with everything that also doesn't have a name that has jit.gl.render. But it's best practices to have a name, because like you might have another patch that's open somewhere else with its own jit.gl.render. You might need to use 2 jit.gl.renders, which is not common, but not unheard of either. So just to save yourself some grief, I always have a name, just as kind of like a fail-safe. So yeah, these are pretty much the same thing. And what's really cool about doing stuff like this is shaders exist for every language you use. Like a shader, there's a certain setup to how you would like a JXS file is different than like what a shader looks like in like WebGL for JavaScript. But 85% of it is exactly the same. Just same. So you can port shaders from other languages, and it'll work with Max if you get it like if you get like just kind of like that 15% lined up, so that it's like set up like a little different. So so that's what's kind of fun about shaders. They're the same for open frameworks, for Unreal, for Unity, for Max. You get insane performance gains and whatnot. And if you really get into Max, you're going to hit a point eventually where you start wanting to do stuff on the GPU. Like you're going to have bigger and better ideas for what you want to do with image processing and systems building. And eventually your CPU is just not going to be able to handle it. So yeah, I encourage you to explore this. I'm happy to answer any questions if you run into any trouble. But this kind of structure will take you 80% of the way there. Just having that jit.world, jit.gl video plane, and then finding the jit.gl slab equivalents, or the JXS file equivalents of your favorite jitter objects. So yeah, have fun exploring that.